Submarines occupy the mysterious world beneath the waves, where stealth, technology, and a touch of the extraordinary converge. These are sleek, silent marvels of cutting-edge engineering that navigate the ocean's depths. Let us take a closer look at how these mammoth machines work. Buoyancy is the upward force exerted by a fluid, in this case, water, on an object placed in it. In simple terms, it's what keeps objects afloat. Submarines are designed to be naturally buoyant, meaning their overall density is less than that of water. This is achieved through the careful design of the submarine structure, which incorporates materials and shapes that displace enough water to create an upward force greater than the weight of the submarine itself. When a submarine is on the surface, it is in a state of positive buoyancy. The combined effect of the buoyant force and the weight of the submarine allows it to float on the water. Buoyancy is primarily achieved by having a hull that is shaped and constructed in a way that ensures it is less dense than the water it displaces. When a submarine needs to submerge, it initiates the process by taking on water into specially designed compartments called ballast tanks. These tanks are located in various parts of the submarine. As water enters the ballast tanks, the overall density of the submarine increases. This makes the submarine negatively buoyant, meaning its density becomes greater than that of the surrounding water. As a result, the submarine starts to sink. The amount of water taken into the ballast tanks is carefully controlled to achieve the desired depth. To control the depth of submersion, submarines use a combination of adjusting the amount of water in the ballast tanks and controlling the buoyancy through other means, such as adjusting the angle of the diving planes, which are wing-like structures on the submarine. Once the desired depth is reached, the submarine can maintain that depth by balancing the buoyant force and the weight of the submarine. Ballast tanks are specialized compartments within a submarine that can be either flooded with water or emptied of water. These tanks are strategically located in different sections of the submarine, and their purpose is to adjust the overall density of the submarine. When a submarine needs to submerge, it begins by flooding the ballast tanks with seawater. This is typically done by opening valves that allow water to enter the tanks. As the submarine becomes negatively buoyant, it starts to sink. The descent can be controlled by regulating the amount of water in the ballast tanks. If more water is taken into the tanks, the submarine becomes denser, and the descent is accelerated. Once the desired depth is reached, the submarine can maintain that depth by carefully managing the buoyancy. This involves controlling the amount of water in the ballast tanks to achieve neutral buoyancy, where the submarine's weight equals the buoyant force, allowing it to hover at a specific depth. When the submarine needs to surface, it expels the water from the ballast tanks. This is achieved by using pumps to force the water out of the tanks. As the water is expelled, the overall density of the submarine decreases, making it positively buoyant. The submarine then rises toward the surface. The ascent can be controlled by adjusting the rate at which water is expelled from the ballast tanks. The crew can also use the diving planes to control the angle and pitch of the submarine as it ascends. Many submarines, especially conventional ones, are equipped with electric propulsion systems. These systems typically consist of electric motors that drive the submarine's propellers. The electricity needed to power these motors is generated by batteries when the submarine is submerged or by diesel generators when on the surface. When the submarine is submerged, it relies on stored electrical energy in its batteries to power the electric motors for propulsion. The submarine can operate silently underwater using electric propulsion, as the engines are quiet compared to traditional combustion engines. Nuclear-powered submarines, on the other hand, use nuclear reactors as their primary power source for propulsion. The nuclear reactor generates heat through a controlled nuclear reaction. This heat is then used to produce steam, which drives turbines connected to electric generators. The electric power generated by these turbines is used to drive electric motors, which, in turn, power the submarine's propellers. This setup is known as a nuclear electric propulsion system. One significant advantage of nuclear-powered submarines is their ability to operate for extended periods without the need to surface frequently for air or to recharge batteries. Nuclear reactors can provide a continuous and reliable source of power, allowing the submarine to stay submerged for weeks or even months. The absence of the need to surface frequently enhances the stealth capabilities of nuclear-powered submarines. They can remain submerged for extended periods, making them less detectable and more difficult to track compared to conventional submarines.
Submarines use control surfaces, including rudders and dive planes, to control their orientation and direction underwater. These control surfaces are crucial for maintaining stability and enabling navigation in the underwater environment. By adjusting the angle of the rudders, the submarine can change its heading or direction. Dive planes, also known as hydroplanes, are located on the bow or front and sometimes on the sail, that is the structure on top of the submarine. Dive planes control the depth of the submarine by adjusting their angle. When the dive planes are angled down, the submarine tends to descend, and when they are angled up, the submarine tends to ascend. The operation of rudders and dive planes is often integrated to achieve precise control of the submarine's movement. Modern submarines typically use sophisticated electronic control systems to automatically manage the positioning of these control surfaces based on the input from the crew and sensor data. Submarines are equipped with advanced life support systems to ensure the survival of the crew while submerged for extended periods. These systems are designed to provide a continuous supply of breathable air, remove contaminants, and manage the levels of oxygen and carbon dioxide. The air inside a submarine can become contaminated with various impurities, including odors, particulate matter, and trace gases. Air purification systems are employed to filter and clean the air, ensuring it remains suitable for breathing. Since submarines are sealed environments, the crew must have a continuous supply of oxygen for breathing. Oxygen generation systems are installed to produce oxygen either by chemical processes or by separating it from other components of the air. The life support systems on submarines are sophisticated and carefully designed to maintain a safe and habitable environment for the crew during extended periods of submersion. These systems play a critical role in enabling submarines to operate effectively and ensure the well-being of the crew in the challenging underwater environment. Submarines are equipped with advanced navigation, sonar, and communication systems to operate effectively underwater, where traditional visual navigation is not practical. Submarines use inertial navigation systems that rely on accelerometers and gyroscopes to measure changes in velocity and orientation. These systems provide continuous updates on the submarine's position and heading and are often integrated with other navigation methods, such as GPS when the submarine is at or near the surface, and celestial navigation using the stars for position fixes. Sonar is a critical component for underwater operations. It works by emitting sound waves into the water and analyzing the returning echoes to determine the location, size, and characteristics of objects in the vicinity. In active sonar, the submarine emits a pulse of sound and listens for the echoes. This allows for precise target detection and ranging. Passive sonar involves listening to the natural sounds of the underwater environment, including the sounds generated by other vessels. This method enhances a submarine's ability to remain undetected. Submarines may be equipped with forward-looking sonar systems to detect obstacles and underwater features in their path. This helps in avoiding collisions and navigating through challenging environments. Submarines use VLF or very low-frequency radio communication when at periscope depth or near the surface. VLF signals can penetrate the water to a certain depth, allowing for communication with other vessels or naval command. Submarines can deploy communication buoys that float to the surface, extending an antenna above the water to establish radio communication with naval assets or command centers. Apart from these, submarines also use ESM systems, that is electronic support measures and advanced signal processing. Periscopes and other sensor systems that can be extended above the waterline play a crucial role in submarine operations by allowing the crew to gather information without fully surfacing. These systems provide a means for observation, navigation, and communication while maintaining the submarine's stealth and concealment. A periscope is an optical instrument that consists of a series of prisms or mirrors to allow observation above the waterline while the submarine remains submerged. Periscopes and sensor masts are typically extended and retracted using hydraulic systems. This allows for precise control and minimizes the risk of damage. The operation of periscopes and other extended sensor systems is often integrated into the submarine's control room. The information gathered by these systems is displayed in real time on monitors within the control room, allowing the crew to make informed decisions. The design of submarines for stealth and silent running involves various engineering principles and technologies aimed at minimizing noise emissions, making the submarine less detectable by potential adversaries. Submarines are designed with streamlined shapes to minimize water resistance and turbulence. This reduces the generation of hydrodynamic noise as the submarine moves through the water. Special attention is given to the shape of the hull, sail, and other protruding structures to ensure smooth flow and minimize drag. Submarines use electric propulsion systems, which are inherently quieter than traditional diesel engines. Nuclear-powered submarines have a nuclear reactor that generates steam to drive turbines, while diesel-electric submarines use batteries for silent propulsion. During critical operations, submarines switch to silent running mode, where non-essential machinery is shut down, and the submarine relies on battery power for propulsion. Crew members are trained to operate equipment and carry out maneuvers with an emphasis on minimizing noise. Strict protocols are followed during sensitive operations to maintain stealth. Exploring the depths of the ocean, submarines are marvels of engineering and stealth, pushing the boundaries of what's possible beneath the waves. From their silent propulsion systems to the challenges of extended underwater endurance, these vessels are at the forefront of maritime technology. So, these were the principles on which submarines work. Until next time, stay curious,